Have you ever wondered what powers the AI revolution? The chatbots you talk to, the stunning images you generate, the self-driving cars on the horizon? It's not magic. It's silicon. And one company, more than any other, is building the engine for this new world. That company is NVIDIA. But how did a business known for making video game cards become one of the most important and valuable companies on the planet, with a market cap soaring past $2 trillion? This isn't just a story about computer chips. It is the story of a high-stakes bet that is paying off in a way no one could have imagined. This is the story of how NVIDIA became the ghost in the machine, quietly owning the future. To really understand NVIDIA's dominance, we have to rewind the clock. Back in the 90s, the digital world was obsessed with CPUs, the central processing units, the brains of the computer made famous by companies like Intel. They were great at handling tasks one by one, very methodically. But a new demand was emerging from the world of video games: realistic 3D graphics. Creating lush, immersive worlds required doing millions of simple calculations all at once, in parallel. A CPU would choke on this. This is where Jensen Huang, NVIDIA's leather jacket-wearing co-founder and CEO, saw his opening. He and his team focused on the GPU, the graphics processing unit. They designed chips specifically for this kind of parallel processing. For years, their biggest market was gamers who wanted the smoothest frame rates and the most lifelike visuals. The gaming community became NVIDIA's proving ground, pushing them to build more and more powerful GPUs. They were building the best shovels in the world for the digital gold rush of gaming. But they had no idea that a much, much bigger gold rush was coming. Around the early 2010s, a breakthrough happened in the field of artificial intelligence, specifically in an area called deep learning. Scientists discovered that the same kind of parallel calculations needed for 3D graphics were also perfect for training neural networks, the digital brains behind AI. Think about it. Training an AI is like showing it millions of pictures of cats and telling it this is a cat. The AI has to process all these images simultaneously to learn the pattern. A CPU would take forever, but a GPU could tear through the data. Suddenly, NVIDIA's gaming chips were not just for playing Doom. They were the key to unlocking artificial intelligence. Jensen Huang saw this shift before almost anyone else. He realized their GPUs were not just graphics cards, they were general-purpose parallel computing engines. In 2006, years before the AI boom, they released something called CUDA. It was a software platform that allowed developers to use NVIDIA's GPUs for all sorts of computational problems, not just graphics. At the time, it was a niche tool for scientists and researchers. In hindsight, it was the single most important decision the company ever made. It was like they built a railroad to a place no one lived, convinced that one day, a city would be built there. And they were right. When the AI explosion happened, researchers and companies didn't have to build their own specialized hardware. They just used NVIDIA's GPUs, which were already powerful, widely available, and most importantly, supported by the mature CUDA ecosystem. It created a deep, powerful moat around their business. Competitors could try to build a faster chip, but developers were already locked into CUDA. Switching would mean rewriting years of code and retraining their entire teams. It's like trying to convince an entire country to suddenly start speaking a new language. It's not impossible, but it's incredibly difficult and expensive. NVIDIA wasn't just selling hardware, they were selling an entire ecosystem, a complete platform. They provided the chips, the software, the libraries, and the tools. They made it easy for anyone, from a PhD student in a university lab to a giant tech company like Google or Meta, to start building AI. This first-mover advantage, cemented by CUDA, is the bedrock of their $2 trillion valuation. They're not just a supplier, they're the foundation. So what does this look like in practice? Let's talk about the products. You've probably heard of their GeForce cards for gaming. But the real money, the engine of the AI revolution, comes from their data center chips, like the A100 and the H100. These aren't just single chips, they are monstrously powerful systems, each one costing tens of thousands of dollars. A single H100 GPU contains 80 billion transistors and can perform quadrillions of calculations per second. And companies aren't buying one or two. They're buying them by the thousands, building massive AI factories. When you hear that a company is training a new large language model, what that really means is they are renting or buying a massive cluster of NVIDIA GPUs and running them 24/7 for weeks or months on end. It's estimated that NVIDIA controls over 90% of the market for AI training chips. This isn't just a market lead, it's a near monopoly. Every time you use ChatGPT, generate an image with Midjourney, or see a recommendation on TikTok, you are interacting with a service that was almost certainly trained on a mountain of NVIDIA hardware. This is why NVIDIA is the ghost in the machine. Its technology is invisible to the end user, but it's the indispensable force powering the entire modern AI landscape. But the story doesn't end with training AI models. NVIDIA is already looking at the next frontier: inference. Training is the process of teaching the AI, which is incredibly compute-intensive, but you only do it once for each model version. Inference is the process of using the trained AI to make predictions or generate content, like when you ask ChatGPT a question. This happens billions of times a day and needs to be fast and efficient. While NVIDIA dominates training, the inference market is more competitive. Companies like AMD, Intel, and even cloud giants like Google and Amazon are developing their own custom chips for inference to save costs. But Jensen and his team aren't standing still. They are developing new chips and software specifically optimized for inference, aiming to extend their kingdom from the AI training factory to every single device where AI runs. They are also expanding into new territories. NVIDIA Omniverse is a platform for building and simulating virtual worlds, or metaverses, for industrial applications. Think creating a digital twin of a factory to optimize its layout before you even build it. They are also heavily invested in automotive technology with their Drive platform, providing the brains for self-driving cars. They are not just an AI chip company. They are positioning themselves to be the computing platform for the next era of technology. So, can anyone challenge the king? It won't be easy. The competition is fierce. AMD is making a strong push with its own powerful GPUs. Tech giants like Google with its TPUs and Amazon with its Trainium chips are building their own hardware to reduce their dependence on NVIDIA. And there are dozens of ambitious startups trying to build the next great AI chip. However, they all face the same colossal obstacle: CUDA. The software moat that NVIDIA built over a decade ago remains its greatest defense. A competitor doesn't just need a better chip, they need a better ecosystem that's compelling enough to make the entire world switch. It's a tall order. For now, NVIDIA's position seems secure. They have the best hardware, a massive software advantage, and the mindshare of the entire developer community. They've played the long game, making a bet on parallel computing that looked like a niche for gamers but turned out to be the blueprint for the future. The rise of NVIDIA is more than just a business success story. It's a lesson in vision, patience, and the power of building a platform. They didn't just chase the market, they created it. By solving a difficult problem for one group of passionate users, gamers, they inadvertently built the perfect tool for solving one of the most important problems of our time: artificial intelligence. That $2 trillion valuation isn't just hype. It's a reflection of the fact that in the 21st century, computing power is the new oil, and NVIDIA owns the most productive oil fields. The next time you see a stunning AI-generated image or have a conversation with a chatbot, remember the ghost in the machine. Remember the company that made it all possible, not by being the loudest voice in the room, but by building the engine that powers everyone else's voice. The future is being built on silicon, and for the foreseeable future, that silicon has NVIDIA's name written all over it. Thanks so much for watching. What are your thoughts on NVIDIA's dominance? Do you think any competitor stands a chance? Let me know down in the comments. And if you enjoyed this deep dive, make sure to hit that like button and subscribe for more content about the technology that is shaping our world. See you in the next one.